Okay, so this is the last part of analog circuits known as feedback amplifier. So let's start with the feedback amplifier. Feedback amplifier. So when we use feedback in series shunt topology, series shunt topology means mixing of voltage and sampling of current. I would say it improves the performance by the new feedback resistance. Let's say I'm representing it by RIF. The input resistance with feedback is R input, which is input resistance without feedback, into 1 plus A beta, which is approximately 100 times higher. This is a kind of improvement in input resistance. And next parameter is ROF. The output resistance with feedback is RO, output resistance without feedback, divided by 1 plus A beta. So what is the idea? In feedback circuit, every quantity which will increase by 1 plus A beta, and every quantity which will decrease by A beta. So new feedback gain can be represented as open loop gain divided by 1 plus A beta. So this is the idea for voltage series combination, which we have discussed yesterday. Now let's take few questions based on this concept so that we can have good idea. So I am writing one question from feedback amplifier so that we can have how feedback amplifier is working. Okay. So this is question from GATE 2013. What this question says, let's say we are having this. We have one input, then I am having one feedback box. Okay. Then we are having one input. This is the input to the system. And this A naught represents the open loop voltage gain. Open loop voltage gain in this case is I am taking A naught. And output of the circuit is I am taking from this point. This is the output of the circuit. And this is output. Right now, this is output without feedback. This is output without feedback. And this is Vin. This network is a beta network. And the ground is connected to this. And this is beta network. And we are having one supply, which is Vi. And this supply is connected to feedback. This feedback is VF, feedback voltage. So the option for this question is, what will be the new input resistance and output resistance if the open circuit input and output resistance are Ri and Ro? So what I can say, you have to check it's a sampling. It's a sampling is what? Voltage sampling. So I can say this sampling is voltage sampling. And this mixing is what? Vi minus Vf. This is voltage mixing. So what I can say, the mixing is a series kind of operation. So it will enhance the input resistance, because voltage mixing is a series event when you have to add two sources in series, and current voltage sampling is a parallel kind of arrangement. So output resistance will be lesser than what we have in previous. So output resistance will be 1 plus A beta, and input resistance must be Ri into 1 plus A beta. So this is the idea how we analyze the feedback amplifier. Now I am taking few questions from complete electronics analog circuit so that we can revise our concept, then we will start new subject. First question is, let's say this voltage is 3 volt. An op-amp inverting terminal is having potential 3 volt. Now this op-amp is connected to minus 2 volt and a resistance of 2.5 kilo. Now the collector, these two collectors are short circuited and connected to a 1 kilo ohm resistance. So I should say this is short circuited and connected to 1 kilo ohm resistance. And this is a 12 volt supply. And a resistance of 1 kilo ohm is connected to this. And feedback is provided through emitter of the BJT. Let's say this BJT is Q1 having operating point Q1. This is Q2. So what I should say, there is a feedback. There is a feedback provided like this. Okay, so I am interested in V output for this circuit. The value of V output for the op-amp Q1. What is the V output for Q1? And beta of the transistor is given as, and output of the op-amp also required for the question. So output of the op-amp is V output of 1. And this potential is 3 volt. The op-amp in the circuit is ideal. So ideal op-amp will not accept any current. So, okay. Can I say the potential here is 3 volt, and by applying the virtual ground concept, what I can say, by applying the virtual ground concept, the V plus is equivalent to V minus. Means the emitter terminal of this transistor is connected to 3 volt. If emitter terminal of the transistor is connected to 3 volt, we have the idea of emitter current. The current in the circuit can be written as higher potential, which is 3 volt, minus lower potential, which is minus 2 volt, divided by a resistance of 2.5 kilo ohm, which says that emitter current in the circuit is equivalent to 2 milliampere. So emitter current for transistor Q1, IC Q1 is 2 milliampere. And these transistors are high beta transistors. For high beta transistors, beta 1 and beta 2 is approaching to, beta 1 and beta 2 are approaching to infinity. If beta 1 and beta 2 are approaching to infinity, what I can say that the current in emitter is equivalent to current in collector. So I can say the collector current is also 2 milliampere. If collector current is 2 milliampere, then I can say this current is coming from the source of 12 volt. This potential drop is what? A 2 volt potential drop, so output voltage is equivalent to 10 volt. Now what I can say, if this potential is 3 volt, the emitter potential is 3 volt, the base emitter potential drop is 0.7. So this is 0.7, this is 0.7. So I can say by applying 3 volt as a reference, by taking 3 volt as a reference, it's a 3.7, and the V01 is equivalent to 3.7 plus 0.7, which is 4.4 volt. So this is the answer for the question. So this is way to analyze. Always go for base emitter junction. The first priority is base emitter junction, and second priority for the question is find some voltage difference and resistance so that you can get current. So I hope this is clear. Okay, good. Let's take one more example. One more question based on combination of op-amp and bipolar junction transistor. Let's say this is one op-amp and I am taking ideal op-amp. Okay. This is ideal op-amp. A high gain op-amp. Input is again 3 volt. So I am connecting 3 volt as my input. And inverting terminal of this op-amp is connected to BJT. This is 12 volt. This output is VO, and this is 2K. What I can say, one collector, one emitter is there, and 1 kilo ohm resistance is connected to emitter terminal. This is 1 kilo ohm resistance. let's say this is one feedback. Okay. So we are in, this transistor is a high beta transistor. High beta transistor means beta is equivalent to approaching to infinity, ideal condition, or you can say alpha is equivalent to 1 for this, because beta divided by 1 plus beta is equivalent to 1, is equivalent to alpha. So when beta is approaching to infinity, I can say the value of beta and beta plus 1 is same, and alpha is equivalent to 1. So this is the idea. Now this transistor is a high beta transistor, so we are interested in the op-amp of output of this op-amp. So to find out these two values, I am giving you 5 minutes. Recording is on. Again, you can apply the concept of virtual ground. So this potential is 3 volt. This potential is 3 volt. So current in the circuit is 3 minus 0, 3 minus 0 divided by 1 volt. 3 minus 0 divided by 1K. So I can see the value of IE for the circuit is equivalent to 3 milliampere. And if this transistor is a beta transistor, I can say the value of IE is 3 milliampere means IC is also equivalent to 3 milliampere. If IC is also equivalent to 3 ampere, potential drop here will be 6 volt. And applied potential is 12 volt and 6 volt is drop across the resistance. So I can say V out, the value of V out is equivalent to 6 volt. So this is one of the answer for the question. And base emitter junction potential drop is also 0.7 volt. So what I can say, if this is 0.7 volt, VO1 is equivalent to 3.7 volt. So this is the idea for op-amp's output and output of bipolar junction transistor. This is question number 3. This is question number 3. Okay. This potential is 3 volt. Then this is connected to BJT. This is 12 volt. This is 1K, and one emitter terminal is there. And feedback is provided by a voltage divider. So I can say this will be the feedback. This will be the feedback. This is our circuit. What they are saying that find the voltage across V emitter. What is the voltage across this terminal? V out. This is V out. And okay, beta of the transistor is given as infinite. Beta of the transistor is given as infinite. And base emitter potential drop for the transistor is given as base emitter potential drop for the transistor is given as 0.7. So this potential is 0.7 volt. And I can say you can copy this 3 volt from here because internal terminal of this op-amp is short circuited because of virtual ground. So I can say the current here is 3 milliampere. And current living or entering in the op-amp is always equivalent to 0. This I minus will not leave the terminal or will not enter into the op-amp in ideal op-amp. So I can say this total current is coming from is taken as emitter current. So emitter current is 3 volts. So I can say this is also 3 volt. So if we start from ground, this is 3 volt and 3 volt output is equivalent to 6 volt. And if beta is infinite, this 3 milliampere current will flow from collector region also. So this potential drop is 3 volt. So output will be 9 volt. And of course, VC is greater than 0.2 volt. If VC is greater than 0.2 volt, then I can say this transistor is working in forward active region. VC in our case is 3 volt and base emitter junction is equivalent to forward bias. Base emitter junction is forward bias. This is a sign of a transistor working in forward active region. So our assumption is our calculations are correct because this correct calculations are only correct for the forward active region. The transistor BJT is working in forward active region. So this is the idea. Now let's take few questions on small signal model of BJT, which is a bit complicated part. So let's start with ideal diode and then we will go for the BJT and MOSFET also. Okay. The first question is, I am interested in the value of VO and IO. And what is given? It is given that these are some of the tricky questions based on the subject. This resistance is 1 kilo ohm. This is V out. This is minus plus. And this is 1 kilo ohm resistance. This is 2 kilo ohm. This is connected to ground. And a non-inverting source is having value of 3 volt. So this source is having value 3 volt. This is the value of current IO which we are interested in. VO and IO is required for this question. So let's start how we can say how this this op amp will work. I can say this part of the op amp, this part of the op amp is a non-inverting amplifier. This part of the op amp is one non-inverting amplifier. And if this is non-inverting amplifier, what is the gain of this? V out can be written as V in multiplied by V in, which is 3 volt, multiplied by 1 plus R2 by R1, which is 1 by 2 in our case. So what I can say, 1 by 2 in our case. So V out for the circuit is given as 3 into 3 by 2, which is 4.5 volt. So can I say output voltage is 4.5 volt? And what is value of current? So I can say this is 3 volt and here current will be 3 by 2 milliampere. And this 3 by 2 milliampere comes from here. So this is plus minus 1.5 volt. And this current is also 3 by 2 milliampere. So I can apply nodal at output voltage. If I apply a node at output voltage, node 8 output voltage what I can say, 3/2 milliampere current is outgoing. 4.5 milliampere current is also outgoing because this is 4.5 divided by 1K. So this is 4.5 milliampere current is also outgoing current. And this is equivalent to all this current is supplied by this op-amp. So what I can say, the value of I out is 3.5, which is 5 plus 3. 6 milliampere is correct answer for 6 milliampere is correct answer for. So there is no direct formula to get the I out. We can calculate by applying the circuit analysis. Now, let's try one more question. We are having one op-amp. This op-amp is having input of 1 milliampere. Positive is connected to ground, and the feedback resistance is 3 kilo ohm. Yes, there is a negative feedback, 3 kilo ohm. And we are interested in the value of IO, VO and IO for the circuit. Calculate this two value. Op-amp is ideal. Ideal op-amp. Try this. So current which is entering here is 1 milliampere because this current I minus is equivalent to 0. So what I can say, this potential drop will be 3 volt. If this potential is 0 due to virtual ground, the what is output of this circuit? The output of this circuit is minus 3. And what is incoming current? Incoming current to the circuit is equivalent to 1 milliampere. So what is value of I naught? I naught is equivalent to minus 1 milliampere. Minus 1 milliampere is the current for the op-amp's current. Let's try one more question, and the question is given by this. There is one op-amp circuit. This is one op-amp circuit. This is negative. This is positive. And one capacitor is connected to this. Capacitor is connected to this op-amp. The switch will close at t equal to 0. Before t equal to 0, switch is open. And capacitor is having value of 1 microfarad. The value of capacitor is equivalent to 1 microfarad. What else is connected? That this terminal is connected to ground, inverting terminal. This is 1 kilo ohm, and V plus is connected to 1 volt. This is the circuit, and what they are asking, VC at 1 millisecond. What is the value of VC at 1 millisecond, and what is the polarity of VC? It is given that VC is given by this. VC is given by this. This is minus, this is plus. What I can say, at t less than 0 or equal to 0, the VC is equivalent to 0 because no current across the capacitor means no voltage stored in capacitor. So this is the idea. This is the fundamental idea, that initial value across the capacitor will be 0. Okay. So let's calculate. When switch is closed, you can say this is one linear circuit. So this voltage will be 1 volt, and this current will be 1 volt divided by 1K is equivalent to 1 milliampere. Current in the circuit is equivalent to 1 milliampere. So 1 milliampere current will flow through this capacitor. IC is equivalent to 1 milliampere. What we know about capacitor, that IC equal to C dVc divided by dt. So this is 1 milliampere divided by 1 microfarad into dt is equivalent to Vc. Vc is a function of time. As time approaches, this transistor will saturate. So you can say Vct for this is equivalent to 10 raised to the power 3 into t. This is a straight line passing from origin. So I can draw that the value of Vct is given by this. The horizontal is time and vertical represents VCT. So I can say this is one straight line passing from origin. So let's talk about this. This is one straight line passing from origin. And what is slope of this? The slope of this line is equivalent to slope of this line is equivalent to 10 raised to the power 3,000 is slope. So they are asking about the voltage after 1 millisecond. So you can say after 1 millisecond, the voltage will be 1 millisecond. The voltage will be 1 volt. So this is the idea. They can ask any question by giving VCT. They can ask the value of T or at any instant of T. They can ask for the voltages. So this is the idea for the circuit. When you are having a transient, the concept transient in BJT. This is one capacitor. Okay. Minus. This is plus. This is 3 kilo ohm. We are having one source is equivalent to 3 sine theta. Then we are having one ground. Then we are having a 2 Henry inductor. What is the V output for this? So we want the output of this circuit for in steady state condition, because the input is sinusoidal. So you can say we want output when t is approaching to infinity. What is frequency of this signal? By comparing it to the A sine of omega t, we can say this complete circuit is operating at the frequency of 1 radian per second. The frequency of the circuit is equivalent to 1 radian per second. So we can find the impedance, the frequency dependent impedance for inductor, and frequency dependent impedance for the inductor is given by Laplace of inductor, S into L. S is what? J into omega into L. What is value of J? Okay, this is one imaginary number. What is value of omega? It's 1. And what is value of inductance? It's a 2 Henry. So can I say the feedback value in terms of impedance, you can replace it by 2J. But this 2J at 1 radian per second. So what is output of this circuit? I can say V out for circuit is given by 3 sine of t V in, and otherwise you can say this is inverting kind of circuit. So Z2 by Z1. Z2 represents the feedback resistance, which is 2 iota, and Z1 represents 3 kilo ohm. So what I can say, 3 kilo and 3 kilo cancel. V out for the circuit is equivalent to, this is minus times. So minus times of 2j sine t, and this is the correct answer. So answer for this question is minus 2j sine t. Let's take some few tricky question based on this. Okay. This is one op-amp. This is negative terminal, positive terminal. This is 1 kilogram, 1 kilo ohm. A voltage source is connected here, minus plus 1 volt. And feedback resistance is also connected. This resistance is having value 1 kilo ohm, and the feedback resistance is also connected as 1 kilo ohm. And they are asking for V out for this terminal. So find the value of V out for this terminal. So how to analyze this question? Let's say this potential is V out. So can I say there will be a current in this direction, and its value is, the value of current I is equivalent to V out divided by 2. So this potential is V plus, and the value of V plus is equivalent to V out divided by 2. If I say this circuit is working in linear region, if I say this circuit is working in linear region, then I can say this potential is also V out by 2. So can I apply the KVL? The KVL for this circuit is given by V out by 2. You can say it's a V out by 2 plus 1 equal to V out. V out is equivalent to Vout is equivalent to 2 volt. If Vout is equivalent to 2 volt, I can say Vout is equivalent to 2 volt. If Vout is equivalent to 2 volt, this potential is 2 volt. So this 2 volt and 1 volt drop, I can say V minus is also equivalent to V minus is equivalent to 1 volt. And what is value of V out? V plus is also equivalent to 1 volt. So this is the idea for the circuit. So you can apply the virtual ground concept here. Transistor is working in linear region. Transistor is working in linear region. Okay. Let's take few example based on diode circuits. This is minus, this is plus, this is one diode, then what we are having, one negative feedback, this is one negative feedback, and a 2 volt source is connected to the op amp. A 2 volt source is connected to the op amp. This diode is ideal and op amp is also ideal. Ideal diode, and ideal op amps are working in the circuit. Ideal diode and ideal op amps are working in the circuit, and we want to know what is output voltage for this circuit. If saturation voltage for this circuit is given as 10 volt, either it will saturate at plus 10 volt or it will saturate at minus 10 volt. So what is our idea to checking whether this diode is open or short? We will apply the open circuit test. Open circuit test. Open circuit test for the diode to know whether this diode will be in conducting state or in off state, will not conduct. So let's replace this diode by open circuit. So we are applying open circuit test, and what is the idea for diode conduction? That Vp minus Vn potential must be greater than 0. If the open circuit potential across the diode is greater than 0, then I can say the diode is conducting in conducting state. So let's apply the open circuit test. And if we apply open circuit test, I can say this is minus this is Vp, this is Vn, and this is this is 2 volt. So what is the idea for conduction? The idea for conduction is V plus V plus minus V minus into AOL open loop gain is equivalent to, let's say this is V01, the output of the op-amp. We know that V plus is equivalent to 2 volt, V minus is equivalent to 0 volt into AOL is equivalent to V01. So what I can say, this diode is on or off? This diode is conducting. And if this diode is conducting, because input is 2 volt at positive terminal, this diode is short. And if this diode is short, what is output of this op-amp? The output of this op-amp is equivalent to, this will be a voltage follower circuit. So what is output voltage of this circuit? This output voltage of this circuit is 2 volt. So this is how we can check the rectifier circuit. Let's take one more question based on op-amp based rectifier. So let's take few more question based on op-amp based rectifier. So let's take this. We are having one op-amp. This is one op-amp. These polarities are negative and positive. This is 2K. This is 5-volt source. Five-volt source. Then we are having one resistance. Okay. This is connected to ground. Now we are having one more diode which is connected to output. One more diode which is connected to output. Then okay, and this is connected to output. Then 1 kilo ohm resistance is also connected to this. This is 1 kilo ohm resistance. This is R. So total 3 resistances are connected. 4 resistances are connected. Okay, and 2 diodes are connected. These diodes are D1 and D2. And saturation voltage for this is given as plus 10 volt and minus 10 volt. This is plus 10 volt and this is minus 10 volt. This is plus 10 volt and minus 10 volt. What we want to calculate? First, we want to know whether these diodes will conduct or not conduct. So let's say, let's apply the open circuit test. So I am applying open circuit test to these diodes. Open circuit test. So let's replace these diodes by open circuit. So D1 and D2 are ideal diode and op-amp is also ideal. D1 and D2 are ideal diodes and op-amp is also ideal. Op-amp is also ideal. So let's see how these two diodes will work. I am replacing all the diodes by open circuit. So we can use this. So let's replace it open circuit. This is my 5-volt 5-volt source. Then we are having one 2R resistance, 2 kilo ohm resistance. Then we are having now we can have one diode which is open circuited, of course. This is VP1. This is VN1. Then we are having one more open circuited here. This is VP2 and VN2. This is whole idea. Now what we can say, a resistance R is connected. So let's take one resistance R. And this resistance is connected like this. This resistance is R, V out. This is our total circuit, in which we are having three resistances. One resistance is connected throughout the. This resistance is 1K. And we are having one more resistance, this. This is 1K resistance. Now this circuit don't have any negative feedback, so this is working in non-linear region. This circuit is working in non-linear region, and if this circuit is working in non-linear region, I can say V out. I am talking about the output of op-amp. The output of op-amp is given by V plus minus V minus into A of open loop gain. So what is the value of V plus? V plus is connected to 0. V minus is connected to 5 volt because no current in the circuit, and AOL. So this is minus of VCC. So what I can say, this is minus of VCC. And if this is minus of VCC, the output is minus of VCC means what? Output is minus of VCC means VP minus VN. This diode is off. This diode is off and this diode is on. So what I can say, what is output for this circuit? The output for this circuit is equivalent to 0. The output for the circuit is equivalent to 0. V out for the circuit is equivalent to 0. So 0 is correct answer for this question. So one of the tricky question from the op-amp circuits. Let's take one more example. And in this example, they're asking about a lot of variables. Okay. So This is 2 volt. Then we are having one diode D2. This is one of the finest question from the diode and op-amp combination. This diode is connected to ground. Then this is connected to this is V plus and this is minus. This value is V out, and V out is equivalent to 1 by 2K. This resistance is 1K. This two diodes are here, and I am interested in this current. This current I, the value of this current I for the circuit. What is the value of current I in the circuit? And I am interested in more voltages. The first one is Vx. Then I am interested in Vy. Then I am interested in I. Then I am interested in VO and V out. So let's take this. It's and there is one more resistance which is connected like this. This resistance is having value 2 kilo. And Vx is labeled here. This potential is Vx. Vy is labeled here. This is Vx. This is Vy. This is V output. Okay, so this is the idea for the circuit. Let's apply the open circuit test and check whether this diode will conduct or not conduct. So I can say if I apply open circuit, the value here will be 0. And this will be plus VCC because the output is positive. V plus minus V minus, I can say for op-amp number 1, let's say output is what? V plus, which is 2 volt, V minus, which is 0 volt, V plus minus V minus into AOL. So this is plus VCC. So I can say for given supply, this diode is not working. Okay. And for given supply, this diode is working. So this is my total arrangement for the circuit. One diode is working, which is D2, and D1 is not working. If D1 is not working, can I say this current is a virtual ground concept? So this current is 2 volt divided by 1K. And 2 volt divided by 1K is 2 milliampere. This current is equivalent to 2 milliampere. And this 2 milliampere is current coming from the output. So what is output of the circuit? The output of the circuit, this is 2 milliampere. If this current is 2 milliampere, I can say the potential drop here is equivalent to 4 volt. And this potential is 0. This is We are going minus to plus, so this potential is also 4 volt. So this current will be 4 minus 0 divided by 1k. 4 minus 0 divided by 1k is equivalent to 4 milliampere. So this current is equivalent to 4 milliampere. Now this current is not coming from here because current entering and going out from the circuit is equivalent to 0. This whole current is coming from here, or this value will be 4 volt. This value will be plus minus 2 volt. So what I can say, this potential is 2 volt and we are going negative to positive, so output voltage is also 2 volt. In this circuit, just we want to check how many of diodes are conducting is a starting point, can be a good starting point for solving this circuit. If you know how many diodes are conducting, then you can find the value of every node voltage and current. How many diodes are conducting? How many diodes are conducting is the answer for the question. If you are able to know that how many diodes are conducting, then it's very easy, because op-amp's terminal will not accept current. This 4 terminal will not accept current. If this 4 terminal will not accept current, you will get the answer. So this is the idea for op-amp circuits. Now I have one more circuit which is given like this. Okay, this is negative, this is positive, this is output voltage. One input is connected to this, so let's take this is my input which is connected to op-amp. This is V in. Then what I can say, we are having one more arrangement like this. And this is 10 kilo ohm resistance. This is 10K. And we are having one more 20 kilo ohm resistance. And one more resistance is connected as okay. One more resistance is connected to this. This resistance is having value 5 kilo ohm. And saturation and plus minus saturation is given as plus minus 15. Plus minus V saturation is given as plus minus 15. So this is the idea. This this multivibrator is known as a stable multivibrator. Can I say this is a stable or bistable? Bistable multivibrator. Bistable this is bistable multivibrator. So what is the output of this op-amp? I can say the output of this op-amp is given by V out for this op-amp is given by Vi. Okay, this is V plus. Let's say this voltage is V plus. So output of this op-amp is given by V plus minus Vi into AOL. And we are interested in the transfer characteristics of this op-amp. I want a curve between output voltages of this op-amp, output and input. I want a transfer characteristics for this op-amp. So how it will work? This op-amp will anyway saturate because only positive feedback is there. This op-amp will saturate, and if this op-amp will saturate, one thing is sure that this V output will stay at plus 15 volt or minus 15 volt. So what I can say, whenever there are two possibilities for V out. So what I can say, two possibilities for V out must be this. Let's say this diode is D1 and this diode is D2. So you can say when D2 is on, D1 is on and D2 is off, because both the diode having opposite polarity, then output will be what? V out divided by 15 is current multiplied by 5. V out divided by 15 multiplied by 5. So this is equivalent to plus minus 5 volt. When D1 diode is on, the output, the V plus can have this value plus minus 5. And when D2 diode is on, and D1 off, of course, this is V out divided by 25, and this is multiplied by 5. So I can say this is V out divided by 5, and value of V out is 15 volt. So 15 volt divided by 3 is 3 volt. 15 by 5 is 3 volt. So there are two choices for V out. So what I can say, let's say D1 is on. D1 is on in this condition. When this diode D1 is on, when V plus is greater than Vi. When V plus is greater than Vi, then you can say this diode is on. So what is the value, two possible values of V plus? So when input is greater than 5 volts, so let's say D1 is on. What is the circuit in case of D1 is on? You can apply a open circuit test. So this is VP1, this is VN1, this is VN2, this is VP2. So what I can say, this is positive value because negative value because Vi is negative. So this is negative value. So what I can say, when diode is open circuited, the V plus minus V minus into AOL is equivalent to V out. What is V plus? V plus is connected to 0 volt. V minus is connected to Vi into AOL. So what I can say, whenever V output is positive, D1 is on. So when Vi is less than 0, D1 is on. And when Vi is greater than 0, D2 is on. These are two conditions for which this circuit will work. Vi is less than 0 and Vi is greater than 0. These are two circuits for which these are two conditions for this circuit will work. So what I can say, let's start with the first condition. Let's say Vi is less than 0 and D1 is on. So I am taking Vi is less than 0, diode D1 is on. And for this condition, what I can say, this is V out, this is Vi, and what is on? It's a D1 is on, so you can say a combination of 5 kilo ohm in series with 10 kilo ohm is connected. If this combination is there, so what I can say, if Vi is less than 0, uh, this is plus V saturation, means this is 15 volt. If this is 15 volt, 15 divided by 15 is 1, so this potential is 5. So what I can say, Vi minus 5 into AOL is output. So what is the range for positive V plus V saturation? The range for plus V saturation is this: 5 plus 2 infinite. In this duration, output will stay at 15 volt, and from 0 to 5. 5 is the point at which this multivibrator will take transition. For this, the output will stay at minus 15 volt. So these are the two conditions. Now, what is the next? Next is, so I can draw this. Output is at 15 volt for 0 to 5. This is at minus 15 volt. At this point, this will take transition. And after 5, it's a 5. This is V out and this is V in. This characteristic is a transfer characteristics. What is next? The next criteria is when D2 is on. And when D2 is on, when Vi is less than 0, when Vi is less than 0, D2 is on. And when D2 is on, what I can say, our circuit will looks like this. And this is This is 5 kilo ohm and this is 20 kilo ohm. This voltage is minus of 15 volt. So what is current? 15 divided by 25. 3 divided by 5 is current in this direction. So you can say if this is the current in this direction, the value of V plus is equivalent to minus 3 volt. So you can say V output for the circuit is equivalent to minus 3 minus Vi into AOL. And now we can check the condition for which condition transistor is working in positive saturation and for which condition transistor is working in negative saturation. So this is how we can analyze the bistable multivibrator. And the curve between V input and V output is known as transfer characteristics. So what we have did in today's lecture, we took some good problems on BJT and op-amp and try to figure out which way is good for analysis. So we have 1, 2, 3. First problem is based on combination of Darlington pair and op-amp. Second one is based on one op-amp, one transistor. Third problem is again op-amp and transistor. The fourth problem is on non-inverting amplifier. Then we have discussion on current source with op-amp. Then we had a discussion about charging and discharging of op-amp. This is one of the good problem. Then a transient. This problem is based on transient and transient plus op-amp. So these two, we have applied this two concept combinedly, transient plus op-amp. These two concept. Then we had a discussion about a frequency dependent circuit, a circuit in which omega is equivalent to 1 radian per second. So we want to analyze a circuit at omega equal to 1 radian per second. Then we had a question in which the positive and negative both feedbacks are available, and we have discussed this in our class, so I don't think more explanation is required. Next problem is problem on op-amp and diode. This is one of the very important class of circuit in which op-amp and diode work as a rectifier, a good rectifier, good but expensive rectifier. Then we had a circuit with two diodes and two op-amps. So this is our discussion for the practice session. Probably from tomorrow we will start a new subject, signal and system, I hope. Thank you very much. End the event.